All right, let's go in with a real quick lesson video for our new unit, solving systems of equations. We're first going to learn how to solve these systems through graphing. And when we're dealing with linear situations like two lines that never cross, this situation right here, these are called parallel lines. They have no solution. As you can see, they never cross each other. This guy's going to continue at this rate. This one continues at this rate. And at no point will these two lines ever cross each other, mainly because they have the same slope. They move at the same rate. Now, right here, this one here has one solution. One solution being right here at 2, 2. We have a solution at 2, 2. That's where the 2 points cross. And for this third one here, it's actually two lines on top of each other. That's why it looks, a little thicker. These lines are twins, all right? So this is going to be infinite solutions, simply because the lines are the same. They are identical, all right? So with the linears, that's how the situation plays out. Either we're going to have no solution, one solution, or infinite solutions. So let's get into it. If we're going to be solving these things, first thing we want is y equals mx plus b, aka slope intercept form. Then we're going to graph them. Going to graph both lines. And then we're going to find our solution, which could be our point of intersection, or the other two options that we previously talked about. Here we go. Here's an example here, and we got one line that's ready to go. The first one is a slope intercept form. So we're going to go to our b value, which is beginning, y-intercept. That's at -3. And then we're going to follow our slope, which is up 1 over 1. Well, up 1 over 3. 1, 2, 3. 1, 2, 3. Put it in reverse. Down and to the left 3. Down and to the left 3. There we go. Beautiful. This is going to be our line. Now, the next line is not ready to go. I repeat, the next line is not ready to go. So what we're going to have to do is we're going to have to put it in a slope intercept form, meaning we got to get y by itself. So I'm going to rewrite the problem so I can do some separate work. I'm going to use the UPS FedEx technique and ship him to the other side. He has to go in front of the 4. So this becomes -2x plus 4. We're going to graph this. And we always want our slope to be a fraction, so I'm going to make it -2 over 1 as a reminder. So this graph starts at +4. The b value is +4. 1, 2, 3, 4. And the slope is -2 over 1. That means down 2 over 1. 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 And we can go up 2 and over 1, given that we have some space. Let's finish with some arrow tips. And voila, we do have a solution. Our solution for this problem is going to be located at this point right here, which is 1, 2, 3. 1, 2, 3, -2. There she is. Any questions, pause the video, or you can even press rewind to get an instant replay. Let's go ahead and move on to example 2. Example 2 has one line ready to go, this guy up here. Now we're going to start him at +2, and then we're going to make our slope -3 over 1, which means down 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. No more space in that direction. Opposite direction, up 1, 2, 3, and to the left 1. These are all my points. Try your best to make a straight line. Doesn't have to be perfect, but not too crazy. And now this next one is not ready to go. We got to do some work for that one. That's a -4. We're going to pick up this 3x and move it to the other side. It becomes -3x minus 4. Let's make that over 1. What do you notice about your problem? Has the same slope as the other one. See how that's going to look. Going to start at -4. -1, 2, 3, 4. And then we go down 3 over 1. Ooh, not enough space. So up 1, 2, 3 over 4. 1, 2, 3 over 1. Over 1, my bad. 1, 2, 3 over 1. These two lines have the same slope but different b values. These lines are parallel. These are parallel lines. Same slope, different intercepts, y-intercepts. Answer, no solution. Real simple. Answer is no solution. Let's go to example 3. Neither one of these bad boys is ready to go. So I'll show my work up here for this guy. -x plus 2y equals -2. We're going to pick him up and move him to the other side. He becomes positive x minus 2. There's a 1 right there. And then we're going to divide by 2 everywhere. So y becomes 1 over 2x equal to 1 over 2x. And your -2 becomes a -1. Start my graph at -1. Then I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. Put it in reverse. Down 1 over 2. Down 1 over 2. Down 1 over 2. And do my best to make a straight line, which shouldn't look like that. Shouldn't look like that. Do better than me, that's for sure. And now for this guy here, let's go 4y equal to 2x minus 4. I divide everyone by 4 and I simplify. I end up with 2 over 4. 2 over 4 simplifies to 1 over 2. Don't believe me? Use a calculator. And 4 divided by 4 is 1. Ooh, these two are twins. They're going to have the same exact points because they have the same slope and the same intercept. All right, so the answer for this is going to be infinite solution. So let's enhance our notes a little bit. We're going to say same line without the dot. We'll use the dot to add characteristics. Same slope. Let's go M for short. Same slope. Same intercept. Answer is infinite solutions. Infinite solutions. Go ahead and enhance your notes with that one. And again, at any point, if you need to pause, rewind, instant replay, make it happen, I'm moving on to the next piece. Right here, we got the quadratics. I'm going to draw a line for the quadratic situation. Right here, a no solution is when the two quadratics never touch. As you can see, these two don't touch. Oh my God. Oh, this says linear to quadratic. So ignore that line I just made. So a line that crosses through, that doesn't touch, yeah, no solution. This one right here that touches at one single point, that's one solution. And two solutions is when the line crosses at two different locations. That's how that's going to look. So if you remember how to graph quadratics, this should go by pretty smooth. Let's move on to... Now, we'll do this part later. Let's get into the work. They start us off real good. This guy right here is in vertex form. We like that. The vertex is at -5, -4. -5, 1, 2, 3, 4, 5. 1, 2, 3, 4. And our A value is 1, so up 1 over 1, up 3 over 1, up 1, 2, 3, 4, 5 over 1. At this point, y'all would be asked to make a table so that you can find these points. That'd be great. Now for this the second line right here, y equals -4. This is a special line. This is called a horizontal line. It has no slope. Remember, slope is attached to x. So we're going to go to -4. 1, 2, 3, 4. That's -4 right there. And we draw a straight line going across. And voila, we see our solution right here at this single point. Our vertex was our answer. Solution is at... what was that? 5, -5, -4. That's where the blue line, the red line crosses. Real simple. Let's get another example. This one here is in standard form. So we're going to have to find the vertex. The vertex is going to be -b divided by 2a. In my calculator, I'm going to type in -2 divided by 2 times 1, which is -2 over 2, which is -1. And my y value is going to be the original equation, x squared plus 2x plus 5. And I'm going to plug in this -1 here. -1 squared is 1. That's going to be -2. That situation there. Plus 5. That's going to be -1 plus 5, which is 4. Cool. So we're going to start our graph out at our vertex, which is -1, 4. -1, 4. 1, 2, 3, 4. -1, 4 right there. Let's make this one blue. All right, this is going to be our blue line. And then we're going to go up 1 over 1, up 3, no space. Up 1 over 1, no space. Here's that graph. Here is that graph. Now for my other line right here, we got to get y by itself. So let's do a little bit of math. First thing I'm going to do is pick up x and move them over here. That becomes -x plus 2. And my last move is to divide by 2 everywhere. This becomes -1 over 2x plus 1. So we're going to start our graph at +1. And then it's down 1 over 2, down 1 over 2, down 1 over 2. Or up 1 and to the left 2, up 1 to the left 2, up 1 to the left 2. As you can see, none of these lines share a point. So this is going to be a no solution. Easy money, no solution. And last but not least, This is a quadratic on quadratic. Draw two parabolas that will show no solution. U and U. They don't touch. Draw two parabolas that will show one solution. U and U. They touch at one point. Draw two parabolas that show two solutions. U and two solutions. Yeah, like that. Yeah, had to use some creativity. See how that works? And right here it says what is one more type of solution for the quadratic system? Chances it'll be infinite solutions. Oh, that means the quadratics are exactly the same. This can happen if one is shown in vertex form and one is shown in standard form. So here we go. We got two quadratics right here. Let's graph those bad boys. We're going to make the first one our blue one. I got to find my vertex, which is negative b divided by 2a, which is going to be negative 2. Oops, change colors on me. Negative 2 divided by 2 times 1. Negative 2 over 2, which is negative 1. And then we're going to plug in the negative 1 into the parentheses. Put that in the calculator. That's going to read 1 minus 2 minus 3, which is negative 1 minus 3, which is negative 4. So this first one's going to have a vertex at negative 1, negative 4. Negative 1, negative 4, 1, 2, 3, 4. Then he's going to do this up 1 over 1, up 3 over 1, 1, 2, 3, 4, 5, up 5 over 1, up 1 over 1, up 3 over 1, up 5 over 1. If not, if you can't find these points by following the motion, you need to use a calculator and create a table. All right. Now over here for this guy here, my vertex is going to be at negative 4 divided by 2a, which is negative 4 divided by 2, which is negative 2. And I plug that into the original, which is x squared plus 4 times x plus 5. And we end up with 4 minus 8 plus 5, which is negative 4 plus 5, which is negative 1. This one has a vertex at negative 2, negative 1. Negative 2, negative 1. Right? Yeah, negative 2, negative 1. Which is going to be right here. Oh, not there. Negative 2, negative 1. It's going to be here. Then we go up 1 over 1, up 1, 2, 3 over 1, up 5, no space, up 1 over 1, up 3 over 1, 5, no space. And voila, we have a solution right here at this point. Right here at this point, we're going to have a solution that we can see on our graph. And that is going to be, what is that? 3, 0, negative 3, 0 for our solution. I hope the video went well. Hopefully you brought some headphones so that you can hear and listen. Good luck. And again, if you can't get these points here through, graphing for weeks, then you're going to have to make tables for these so that you can know exactly where those points go. So that's the end of the video. Signing out.